Hello and welcome to the SDK training for InsightCM 1.0. What we're going to start today with is coding. And the goal of the next few videos, really the rest of the videos in this series, is to show you how to take an existing data logger and add InsightCM and add it to InsightCM using the SDK. And what I mean by adding it to InsightCM, I mean that you can get its configuration from the web, that the data files produced show up in our Data Explorer, and the server will consider the device an authorized device and collect its data files automatically. So what my goal is that you would be able to use the SDK and add it to any data logging architecture. I don't want it to be specific to the example here, so I'm going to try to keep things generic, but for the purposes of demonstration, I have selected a data logger that we'll be programming in live. And the one that I've selected is the cRIO vibration data logger. It's one that I'm familiar with. It's been out for a very long time, way before InsightCM came out. And so I'm familiar with it, and I've used it, and that's the one we'll be demonstrating here in this video series. But before we open that up and start coding, we need to get all of our prerequisite files together, starting with the SDK itself. So over here on the left, we have the distribution of the SDK. It is not an installer. It's not available on the web. If you want it for your application, your opportunity, you typically need to talk to someone at corporate or talk to myself, and we'll try to line that up for you. But when you get the SDK approved for it and get the code, it will look like this. It's just this zip file. And you have to start moving files around manually to install it. So you'll open up, and I'll say this is just for InsightCM 1.0. When InsightCM 2.0 comes out, the SDK will be much more polished. It probably will have an installer, and you'll probably get another video series for that one as well. But for 1.0, this is how we're doing it. So open up the SDK EAR directory, and we're going to drill down a little bit. We have InsightCM. And open up the SDK, and open up examples, and here's this README. This README will show you where you want to copy files to in your vi.lib directory. Also, you'll see later that we're going to put a component on the cRIO itself called SDK 1.0, and so there needs to be some files copied into your RT images directory, so there's examples on that. We have the list of there are a couple examples themselves in here which might be useful to you, and this is what must be on your cRIO for those examples to run. Here's a list of messages that you'll get from the server and that you can send to the server. We'll get some experience with that here in this video series. But this is how you install the SDK. It's a manual process, but that's what you got to do. Then in here in the middle, we have something called Insight files. It's kind of a poor name for it, but this is example code that I have written for the purposes of this video demonstration. And inside of here, you'll get things like a dispatcher. There's an API, a data logging API that adheres to our TDMS schema for InsightCM. Let's open it up here. So there's also an example plugin definition file for the vibration data logger. See, I did all this ahead of time to save time in the video, but also it's something that you can get your hands on and use for example code if you think that's helpful to you. You can, of course, write all this yourself. This is just example code for this video series. You can find this on the NITalk page where I'm going to be linking all of these videos. This is where you will find this section of code. And then finally, we have the architecture itself, and we have again selected the vibration data logger. And if you don't have it, let me show you briefly how you can get it. You'll open up Chrome, and you can type cRIO vibration data logger, and it's your first hit right here. And you'll get this DevZone document. There's some documentation here which talks about the prerequisites for it, like GXML, waveform reference library. Shows you how to create the project. It shows you the general layout of the project, though that's probably an old screenshot. And It also has the software that needs to be on the cRIO for it to run, link to a discussion forum. But what we're really after here is this package. So here in the top right, we have version 5.2 or later. And the example code that will be showing off here, that's in that Insight files directory, the dispatcher and the mutex code and the data logging API, it was all developed to work with 5.2. And so make sure you get 5.2 here or possibly later. I'm not sure if we guarantee backwards compatibility, but you'll definitely want 5.2 if you have something earlier. So you'll want to download that, and the nice thing about package is it will bring in all these dependent packages automatically. So I download that and I installed it. And when you bring up LabVIEW, you'll click Create Project. There's lots of example projects here. We'll filter it on Compact Rio. We'll use the vibration data logger. This was an SE developed architecture. There's also this R&D data logger called LabVIEW FPGA waveform acquisition and logging on Compact Rio. I've never added this to Insight. That would be an interesting exercise. But I'm more familiar with this one, and this is the one we'll be using. So I'll hit Next. And it'll ask you for a name, where you want to save it. Do you want an overlay? And then when you hit Finish, it'll create the data logger. Now, I went ahead and did this already. I named it cVDL Orion. I did this for two reasons. First of all, to save a little time in the project creation, but also you have to compile the FPGA, and I wanted to do that ahead of time as well. So I've already hit the Finish button and created the data logger. So you get a little artificial skip here. But inside of here, you have the project, the cVDL Orion.project, and you can see I've already compiled the FPGA. And we'll just open this guy up. And here we go. We have an FPGA VI that talks to the RT VI. This is where the majority of our SDK development will go. And there are a series of host VIs which are used to configure the target, to view live data, and then to view data files. Now again, what we're going to be doing here is trying to configure from the web. We're trying to configure things from the web. We want to see our updates from the web, and we want to see our data files from Data Explorer. So really, we're trying to obsolete these parts of the vibration data logger and bring it into Insight. And then also have, of course, the files automatically transferred. So let's run this thing, and you can kind of see how it works. We'll connect to it. And let's open this up. This front panel is a debug front panel. And since we are going to do some development, let's go ahead and enable this debug front panel. Enable this subdiagram. Very good. We'll talk more about this block diagram later, but this is just a debug front panel. It's looking at some metrics like CPU usage and space available, current state. These are all being just pushed to a global variable so that I can view them in a debug front panel when I'm developing. But when it's time to deploy, I'll disable that, as it was disabled when I first opened it. So this is the RTVI. This is the XML. This is the configuration VI. It writes to XML. But it has some things like the number of channels, sensitivity for the channels, a sample rate, samples per read, pre-trigger blocks, how big my data files are going to be in terms of blocks. I'm sorry, the snapshots are going to be in terms of blocks. Got some file properties in here. Just your basic run-of-the-mill configuration parameters. Then I have this test panel, which I can connect to it and view some live tags or metrics. Got some waveform data that I can look at, and I can remotely force trigger data capture and then remotely reboot the device. So that's some commands in there. And then this is the file viewer that I didn't write this. This is in the TDMS palette. It's a real low level thing. I really like it for debug. And I just linked it in the project here. This is just straight out of the palette though. So let's go ahead and run this thing and we can see how it works. I have already put a configuration file on the cRIO. I used this create config xml.vi and I moved that VI to the cRIO. And here we go, we're running. You can see the configuration string is displayed here. It's in a check trig state. Time here looks pretty good. Buffer backlog is nice and low. All this looks really good. CPU usage is very small. This is a very basic data logger, so we should have lots of resource margins in our resources here. Space available. This is our hard drive space. There's lots of hard drive space. This all looks really good. And now that this is running, we can launch this test panel view, and we can look at. I'm expecting to see some metrics here, and I am. Very good. So to make sense of this, let's look at what's connected. On AI0, I have a sine wave. On AI1 and 2, I have nothing, and on AI3, I have a square wave. Very, very nice. Looks very good. So if we look at our metrics, we can see our RMS for AI0 is 1.4. This is as expected. The speed is about 600 RPM. This is also as expected. And we're getting all the same tags. We have 2 files on here in the hard drive, and we're in the check trig state. So one of the things that we can do is hit this button called force trig. And we have now gone into the writing file state. We're going to write 20 blocks because that's what it was configured to do. And we should see our number of files go up to 3. And we do. Very good. This thing is working nicely. And if we want to disable it, or since we're in debug, if we want to turn it off, we can hit this restart target. If we were deployed, this would actually reboot it. All right, and he responded. Very good. So this will be our architecture moving forward. I'm not going to spend any time on the block diagram yet. That's going to be future videos. But this is how it behaves, and again, the goal is to bring this into Insight. Minimize this stuff. So the last little piece of bookkeeping here is we're going to take this Insight files, and we're going to bring this into cVDL Orion, and we'll just drag it right here on the same level as the project. And inside of the project, let's take Insight files and bring it into main subVIs. And there shouldn't be any conflicts or anything. And inside of here we have our 4 directories and our plugin definition file, which we'll get to in our next VI. Our next video, and there we go. I think we're ready to begin. So we have all the code together. We have our example code in the project. Our SDK has been installed according to that README file, and we should be ready to go. We'll see you next time.